Hello, I'm Mark, and welcome to part 2 of my Unreal Engine tutorial on how to build a multi-stage and non-linear questing engine for your Unreal Engine games. So in this video, we'll be building the quest object, which will serve as the container for the respective quests that it will be managing within our quest log system, as well as building out all of the supporting structures that are going to be needed to store and track the progression of a quest through its life cycle within the game. So without further ado, let's get started. Okay, so in part 1 we went ahead and we stubbed out a couple of objects, which was the questing interface as well as the quest log component, and we'll get back to those in part 3, but I wanted to stub them out because there are a couple of little dependencies we needed in part 1 for these table structures. And then the majority of our work was actually building out the questing table, and so now that we've got the questing table, we'll be able to configure all of our quests so that we can then feed them into the quest log for management within our game. And we'll get back to this table, I think, around maybe part 4 when we do the integration, where we can then start playing with all of the components in their raw form before we start adding UIs around. But for this tutorial, we're going to just jump right into the quest container object, which will be managing each individual active quest within our system. So for starters, I'm going to go ahead and build some more structs. These are actually going to be state structs now versus table structs, and so I'm actually going to put them into a new file. So to do that, I'm just going to come back to our solution here, and I'm going to go into the content drawer. I'm going to come down to classes, call it public and questing, and I'm just going to right click and say new class. And again, since Unreal Engine doesn't do structs within the editor, we're just going to go ahead and create a new struct file for ourselves using the none empty C++ class. So I'm going to do that. I'm going to hit next, and we're going to go ahead and give this a name. So this is going to be the state data. So it's separate, again, separate from the table data. And this is the data that is going to be used to track the state of an individual quest. And it's also going to be the data that we're going to also use for archiving purposes, as well as data that is going to be then saved and reloaded through the save system, and as well as other data that we might want to push around just to make our lives a little bit easier when we get to UI components. So that's going to be living under the core quest state data, so that's what I'm going to name it. So I'm putting it under public and in the questing folder, and let's create the class. Just take it a couple of seconds. And it's compiled. All right, so let's go ahead and bring up our Visual Studio again. Let's reload everything, and there's our new state data object. So as you can see, it's a class, so we need to convert it to a struct. So the first thing I'm going to do is I'm going to go ahead and convert this over. So I'm bringing in the generated H. Make sure again it's at the bottom of your include stack. And let's go ahead and just put the prefixes. So Unreal Engine likes to have any structures defined with an F in front of it. Let's make this a struct. So it's now a struct, and we'll give it a type blueprint real quick. And of course, because we're using the generated.h, we also want to put in the macro for generate body. All right, so I'm going to hit save. All right, so we'll get back to this. Yeah, so this is the main state structure, which will be living within our core quest object. And I like to use this as a way of being able to aggregate all the variables that we need it just makes it a lot easier when I get to saving and loading just to grab a struct and serialize it versus having to grab all the loose variables and then put them into arrays in a save and then hope you get the right ones in the right order. This just makes it a lot cleaner and easier to move things around as a continued data object. So that's what this is. All right, so again, just like with the data table, we'll get back to this since this is one of the larger structures, and we want to create some substructures in here. Another thing I'm going to do is I'm going to go ahead and add an include to the table row that we created. Because we're going to need some structures out of there too. So there we are, call quest row, hit save. All right, so let's get started. So the first thing I'm going to do is I'm going to create an enumerator, and I'm just going to put this up top. So this is an enumerator which is going to be used by our questing engine to know where we are within the quest state. And this is actually going to be used at the quests, at the stage, and also at the objective. So this enumerator can be reused, is going to get a lot of reuse. Again, we have in progress, which is okay, as soon as the quest starts, it's going to be in progress. But then we might want to know if the quest, stage, or objective is is pass, fail, or if it's branching. So again, it's just a nice little enumerator to kind of give us an idea of what state we're at within the life cycle of the quest. All right, so next I'm going to bring in some archiving structures. And so these archiving structures are purely for quests that are either in progress or being completed, right? So we want to save this information, archive it, so that once it's complete, we can save a copy of the history of how the quest played out, or but we're also going to use it as a way of just tracking the progression as well. So it's going to work. It serves two functions. So this is the core quest objective history, and as you can see here, this is objectives. We have the progress amounts. We also have the outcome, and we've also got our first implementation, which is an update objective progression. And this is just a little function I created just to make things a little bit easier to manage when we get into the code. All right, so I'm just actually going to take these out for now, and I'm just gonna do that there, just make that a little bit easier, make those green squiggles go away. All right, so let's go back. So this is our first function, which is the update objective progress. And so let me find that. Here it is. And all it's going to do is it's just going to take the value, and we're going to do an overloaded operator plus equals. So this is just going to say take the amount here, add this, and put it back into that. If you're not familiar with overloaded operators, that's all that is. Nice, quick, keeps it all together. I suppose I could have one-lined this, but I'm just going to keep this in a separate function for now. All right, so again, this is just a helper function that I've got on the struct. These structs, unlike the table structs, are going to have a lot more helper functions because there's a lot of things that we're going to be doing actually on the data within the struct. So for me, I kind of like to keep the that functionality close to the data. That's one of the nice things about C++ structs in doing it this way. All right, so that is it for our history data for our objective. So now the next history data is going to be at the stage. And again, I'm just going to go and change the tag. I'm just going to minimize this, and we'll minimize that. So here's our stage history. So that was objective history. So that's recording the current state of the objective. This is going to be recording and updating the current state of the stage. And so within here we have a map of objectives that we're tracking. So we have the name and the objective. And then under here, we've also got the outcome. Again, you know, did we pass this stage, fail this stage, or is this stage being used for branching out into other stages? So again, so pretty quick. No helper functions here. This is just purely structure. And so then the next one is going to be, after stage, is actually going to be the quest. And this one's going to be a little bit bigger. So again, I'm putting these in a specific order to help with the compiler. So that's kind of why I'm kind of pushing the state down. And we'll get to the state once we've got all the individual other structured pieces of that data. And again, everything here is going to be blueprint read writable. As you can see here, I'm using the property blueprint read writable because all of this will actually is going to need to be serialized into the save and load for save and loading purposes. So when we save a game, in order to serialize these straight into the save load file, we just need to make sure it's blueprint read writable, and that will indicate that these properties are going to be saved as data for us. So we'll just bring this back. All right, so for the quest history, again, now we have the actual row handle. So we want to save this row handle that way, because the row handle has all the additional information we may need for kind of that creating quest log UIs. And anything else we might need. So we don't need to, so this is just going to point back to the actual quest we want. And then this is the history of the stages. So just like stages had histories of objectives, quests have history of the stages, the stage that's been completed. And then we also have the overall outcome of the actual quest. Did it pass, fail, in progress, or is it this one quests really don't branch, so but we're still just going to reuse this state object. But this will tell us if we actually passed or failed it, and that will then go in, and that will then go into the history once the quest is completed. So we'll have that running history of all the quests and what happened. And here we're actually going to be, I created a little overloaded function just to kind of set this up, since we'll be creating these structures when we create a new quest. So again, it's the row handle, so handle goes to there, and then we have the core quest history. So what we do is we just go ahead and just create that map and put that in there as our completed stages. All right, so that is the archive code. So now we're ready to come back to our quest state data. So now we can come back to this object and start filling this in. So I'm just going to bring in all of the variables first, since it's a pretty large object. And again, this object is also going to get serialized. So we have a serialized set of structures. But again, so here we have the data table row handle. So again, this is all the information for the quest. So all of our quests will be passed in by row handles. But that way, again, and this gives us the ability to partition our quest tables into smaller questing tables to make it more manageable. Then we also have the core quest stage. So this is the current stage, and so again, like I said, our system is going to work more like a state machine. So so to keep things a little bit more efficient, I'm just going to keep the current stage, and then this stage is defined over here in core quest row. So we just keep the current stage, and then we also keep the current quest stage ID. So this is kind of how we are going to be moving to the next stage. As we update the quest ID, it will then do, manage making sure we get the next quest, and then we just put that into this temporary variable here, just to make sure it's a lot easier for us to access the information we need. Because while we're non-linear, we can only really participate in one stage of a quest at a time within the context of that quest. All right, and then we have the quest. Yeah, then we have the core quest stage history. So this is our history data that was built out up here. Core quest. So this is the core quest stage history. Again, we just keep updating this, and then once it's updated, then we will then push it onto the core quest history. So again, I'm just keeping some additional variables here just to make it a little bit easier as as we continue to operate on that stage. But then when we move to the next stage, then we'll kind of move things into these into the core quest stage history system and run it that way. So again, this is just a flag. This tells us if we're ready to turn in a quest. So this kind of goes into the concept of when is a quest actually complete. So there's completing all the stages, but a quest really is not complete until you're ready to until it's been handed in. So this just tells the questing engine that we've got to the end of all of the stages that we care about. Now we're ready to just hand it in. So once this flag goes from false to true, then we can go back to the quest giver, or if it's an autocomplete, it will just auto-complete it. But this is what triggers the final completion. Whether we go back to the quest giver and the quest giver will say, okay, let's turn it in. Or if it's autocomplete, it will then automatically go and turn itself in. This is the current quest history. So here it is up here. So this is just the running history that we're keeping. And then these variables are the total accrued XP, accrued currency, and this is the accrued rewards. So this is how. So as I said earlier, the system you can break things up if you want to. It's up to you on how you want to manage XP and rewards in your game. But this system will, depending on where you put it, will start to tally that up for you. So if you wanted it to give different results based on passing and failing stages, you could do that right here. And so this will go ahead and accrue it for you. All right, so that is everything for the variables. And again, all of these are read-writes, so they can be completely serialized into the save and loading. So next, we need helper functions. So I'm just going to go grab all of these so that we can start to implement these. So again, because this is a state struct, and there's a lot of data that's going to be moving between states within here, I'm electing to put the functionality in with the struct. All right, so first off, we've got our get quest details. So this is our ability to get the actual quest details that we need. And again, this is a constant, so this is a read-only function that is going to pass back a row, which is our core quest row. So let's go ahead and get that implementation going. And all I'm going to do here is, so again, because this is a row handle, I want to make sure that this row handle actually has a table associated with it. So otherwise, if we try to execute this and this table is null, the game will throw a hissy fit and crash. So we just do a quick little pointer check, and then once we do the pointer check, then we'll do the row. We don't need to worry about this. If this is none, then this will return a null pointer. If its table is none, it will return a null pointer, so everything else is good. But this is fine, the active quest. So that's there. Again, these are just simple little utility functions to make life a little bit easier when we get to the actual object as well as to UI components. All right, so get quest objective. So this is putting in an objective ID so we can actually get a quest objective out. So I'm just going to do that. So here's our quest objective. So again, this is the current quest stage. So we can only get quest objectives on the current quest stage. So there's the ID. So what we're going to do is we're going to iterate through the quest objectives until we find the objective with the matching objective ID, and then we'll return that. And we're returning a copy back of that objective. All right, so come back here. Is valid table. Again, this is just a way for me to check to make sure that we have valid table. Just a quick little check. So all it does is it goes through and says if this is valid, if this is a valid pointer, return true, otherwise false. Again, just a little table check. Okay, so whenever we start a new quest, we need to initialize the quest data. So since the quest data is hanging out here, we can just do it right here. And we'll see this more as we start building on top of it. But again, these are just all little supporting functions to make our lives a lot easier when we get to when we get up to the quest object and then into the quest log. All right, so again, initialize quest data, check to make sure we have a valid table. Then what we'll do is we'll go onto the row and we'll get the row, and then we'll check to make sure we have a valid row because again, this is a pointer. So if the row is valid, I'm going to go ahead and get the keys. And then what I'm going to do is I'm going to go for each key, we're going to go to the first stage and we're going to put that K, which is the key, into the stage ID, and then we'll break. And that's all we're doing here. We're initializing the quest. So we're going to set the current quest stage to the first stage in the stage map. So, and that's the assumption we're going to make. This, always the first stage is in our stage map table, which is here, right? So the first one here is always going to be that's the first stage. That's the entry stage into our state machine. So we set that, and then what we're going to do is we're just going to take the quest details, make sure we put a copy into the history, and then we're going to set our history objects. So again, this is just initialization. So this is what happens when we pick up a new quest. And then once we pick up a new quest, we also need to initialize the first stage of that quest. Or a stage of that quest, really, so we'll actually be calling this will only get called once when we do add. This will get called every time we need to move to a new stage, so hence this is kind of moved into its own function. So let's just minimize that, and again, going into the table, we're going to get the row, and now this time, since we have this, we're just going to go ahead and put that into the stage there. And so now we've got a copy of the working stage that we want. And then from here, we're going to then go into the current stage history objective progression, make sure it's empty. And then we're going to set the stage to in progress. So this is our history data. And then from here, current stage, quest objectives, current stage objectives, progress. And then this is where we start initialize. And this is just purely initialization. Core quest objective history. So again, we're just initializing the array because this is where we'll be then updating the progression of these objectives as we progress within this structure. And again, this will happen every time we move to a new stage. So again, hence that's the reason why we only just get this ID here and we don't do anything else. Because then this again gets called, and that's what actually gets the actual stage for us there. Okay, so next up is set the next stage. A little bit redundant there. And we actually have two of these, so this is actually an overloaded function. The names are the same, but the signatures are coming in are different. This is taking in a bool, this is taking in an objective ID. So this one is going to be used for when I'm using for doing branching. This is going to be used for pass-fail. And all this does is it just allows us to move to the next stage that is being defined. So the first one is the objective ID. So if we bring in an objective ID, we're going to go ahead and set this to outcome to passing by default. And then we're going to run a function called archive quest history, and we'll get to this when we probably next, after we get through these ones. And so we'll archive the history, and then we'll go ahead and set the next stage ID. So this is going in, we'll go into the current quest stage, next stage branch. Remember, this is a map based on using objective IDs to find the tag that we need to set the next stage to. So that's all that does there. So if it's a pass-fail versus a instead of a branch, we need to do something a little different. First, we're going to say if it's a passing, we're going to take outcome passing, archive the history, and then we'll look at the next stage, all success, and put it in there. Else, otherwise, if it's failing, we'll set the outcome of the stage history to fail. Quest history, current quest stage ID is failing, that's the failing tag. And then we'll set this to none, or we'll check to see if this is actually none. Because if this is none, then we're actually going to say, okay, then the whole quest is failed. Where if this is not none, right, we actually have a stage to move to, then we're going to say, okay, well, we haven't failed the quest, we just failed a stage on the quest, so now we have to go to the consolation stage instead. And then we do another check here to say, this is none. And this is just to kind of clean things up. So if we're exiting, if we're exiting the quest, right, we just want to make sure that we set this to reinitialize this so that the engine doesn't pass back any dirty data as it's kind of processing the quest. All right, so that should do it for next stages. So then we have archive quest history. So this is now moving all of that information into our archive. And that's all that does. It's just taking, and again, I put this in its own function just so because it's being used in multiple places, just makes it a lot easier. It just takes the current stage ID and the current stage history, and we just put those together. All right, so now that we've got the archive, let's go to the next function, which is the get quest history. And let's just go ahead for real estate purposes and set that up. So get quest history, again, just a quick little function. These are all lots of little functions, but they're here because they get reused over and over again. Get quest history, so this is just allowing me to get the history. So this just says take the details, take quest details, put it into the history, and then return the current quest history. This just makes sure that this is actually using the right row handle and it's all set. Before we pass that back, update stage rewards. And this is our aggregation system for our rewards data. So as we kind of move forward, we'll be calling this. So all we're going to do is, again, we're just using the overloaded operator here and here. This is for XP. So this is taking the current stage rewards. So this is the rewards which is outlined in the data table, right, for XP and currency on the stage, and then we just put this into the accrued values here. And then what we're doing here, since this is an array, we're just going to take the array here, which is an array of inventory rewards, right, and we're just going to append it to this array. And so this allows us to keep, as we keep appending, we can create we can keep adding to that array over time the rewards in there. All right, and then we have the objective rewards. Objectives is a little different because they can have multiple objectives on a particular stage. So here again, if we have rewards on here, we'll go ahead and do that if it's passing. So if it's 0, we'll be passing zeros. If there's nothing in the array, we'll just be appending a blank array, so we don't have to worry about it. But all this does is it just accrues for us. And then this is for each objective in the quest. And when we get to here, as long as the objective rule is passing, it's a passing objective, we'll update it and do that. Okay, and then lastly we have the update objective rewards. And nope, this is the updated this is updated objective rewards by objective ID. So what this does is it's just going to go ahead and we'll get the quest details from the row. Oh, wrong one. That's the one we want. There we go. Objective rewards. There we are. So all this does is this says update the objective rewards by the objective ID. So all we do is we just iterate through and we'll only accrue by the objective ID that is coming in. Versus this one just updates all of the objectives wholesale. All right, and then finally we have update quest rewards. And that's the one which I was going to put in here. So again, this is just easy. Just go get the quest details and then we'll just accrue right here. It's the same idea. We're just doing it at each different step. All right, so that should do it for all of our state logic. Okay. So that is our core. So this is the archive. This is the actual quest structure, which will be residing within our quest object when we get to that. So next on the list of things is going to be our save system. So, and I'm just going to put that in here since it's, again, it's persisting data. And I'll just put a little tag there too so you can kind of see it. And let's just go ahead and grab this guy real quick and minimize it. All right, so this is again for specifically for saving and loading. So the only things that we care about for saving and reloading is the current active quests. So this is all the state data here. We're just going to put this into an array. This is completed quests, which is our history data, right? And that will be put into an array. And then this is for tracking. So if we have anything in our tracker widget, we're just going to put the IDs in and we're just going to put that there. And again, all read writable. So the idea here is all of these structures are all read writable in the edit anyway, so they can all serialize up as a single structural unit within a save file. So it'll make it a lot easier to grab that data and save it and reload it. All right, so that's that one. Next is going to be the quest log update structure. So this is just a helper function. This is a helper structure that I'm using to allow me to update the quest log. So all it does is it takes an objective ID and amount, and we just put that in. And so this is going to be fired. This is going to be passed into a delegate, and it's going to be and this is what gets broadcast to all of the objects to go check to see if they have something to update. So we'll be using a parallel processing way, a parallel way to check all of the active quests and make sure that we can update any current objectives that way versus using an iterator. All right, so that's there. And then finally, I've got one more set of structures, and it's going to use an enumerator and a struct. And this is going to be useful later on when we do the progression list. So the first part is the what type of progression type is this? This is update, stage, or objective name. And then I've got the struct, which I'm just going to put here. And we'll go change that tag. And this one is just we've got, yeah, this is just sending in the type. So this is something that will get broadcast up to the UI. And we broadcast it from the quest up to the quest log, and then from the quest log it'll get relayed into the message queue for the UI, and then we'll pop these off the message queue so that we can display them in the UI. So that's kind of how it's going to work. So that's there. So here it's just a bunch of data. So, and not all of these variables are needed for each one, but it's there to kind of be as comprehensive as I can make it. But again, it's going to be what type is it? Is it going to be a quest update, a stage update, or an objective update that's going to be surfaced up to the UI? If it's a quest, we'll have the row handle. If it's a stage, you'll have the row handle and the stage ID to find it. If it's an objective, we'll have the objective ID. The outcome, this could be for both stage, quest, and objective. And then the amount, this is usually just for the objective. All right, so again, this is purely for messaging, so quest progression message. All right, so that should do it for all of the structures we'll be needing for this whole solution. So we have the table structures, and then we have the data structures. So now we can actually move on to some we can move on to the quest container object, which will be actually managing the quest and will act as the engine to keep moving the quest forward as we continue to progress through the game. Okay, so to make the quest object, let's move back to the editor. And I'm going to come to the content drawer, go to C++, and we're going to come to the public questing, and we're going to right click and go to new class. Now for this, I'm actually going to be using the object class. And the reason why I want to do this is that it'll allow us to keep each quest as its own object. And when we spawn it in, it will spawn it into Unreal Engine's memory management table, and it will then manage that class for us. So again, we're just going to use object. Some people use actors. Some people, I don't like using the actor only because there's just a ton of overhead. Actor really is an object that takes up space. Here, I just need this for memory. So I'm just going to use the object. And this is the base object for nearly everything in Unreal Engine. So anything that you create, any components, any actors, characters, pawns, they all refer to the object base. So that's what we're going to do. So I'm going to hit next. And this object is just going to be called I'm just going to call mine the core quest object. And this is the container for each living quest as we continue, as we're, and this will be managing managing each quest within our quest log for us. So I'm going to hit create class. All right, and we'll come back to here, hit reload all. All right, and so Unreal Engine is gone ahead and created us the generic object for us. So again, this is our generic U object, which can now reside in the Unreal Engine memory table. So let's go ahead and fill this out so that we can turn it into our quest object. So first off, let's get some includes in here. We're going to need includes to both the row as well, to the table as well as to the state. So we're going to say and include. I'm going to say core. Oops. Pound include. That's the row. And that's the state. All right, so that's the only things we need here. Everything else is pretty much generic. I'm also going to put in some meta tags. So this is blueprintable. So this can be then seen in the editor because we're going to need to get access to this in the editor when we start building some UI components. So that can help us there. And then so the first thing we're going to do within this object is actually define our delegates. So let's go ahead and do that. And there's a bunch of them we're going to be putting onto here. So this is going to allow us to broker communication between the actual quest as well as so this will broker communication between the quest and the quest log, but we're also going to add some event triggers here for when we also want to use this same object in the quest log UI component as well. So here, all we're going to do is we're just going to declare some dynamic multicast delegates. So the first one is going to be. So this one is like, so the first one here is the check external objective call. This allows us to check go up to the host and check if there's anything we need to do on the host. So this is useful when we do a collection quest where we may say, okay, I need to go out and I need to collect like 10 apples, right? If I already have 10 apples in my inventory once I pick up the quest, this will do a quick check first to see if we've already completed it, and if we have, then it will then tally it up. Or if we've partially completed it, it will then allow us to do that for us. So again, all we're doing here is it's a one parameter, and we're just passing up the objective ID, since everything is being tracked through the objective ID. The second one is the quest progression update. So this fires every time. Whenever we make an update. So if we're moving from stage to stage, this will fire. If we've completed an objective, this will fire. Once we get our quest to the point where we can hand it in, it will fire. And again, and this is what's using the quest progression structure that we defined here. Right here, the messaging structure right there. And then finally, this is the time tracker. So one of our options is to have a timed objective. So this allows us to broker communication between us and the host, and the host will actually be the component that actually does the ticking. But we just we need to tell the host that we actually, when the time is right. That we have an objective that we need it to track time on for us. And so this is a 2 parameter instead of a 1 parameter. So note the name 2, and instead of param, use s. And then we're just going to pass up a reference to ourselves, which is the quest, and we're going to pass up whether we want to turn the tracker on or off. So, and that's what that'll do. And then down here we have the autocomplete. So if this is a quest that is set to autocomplete, we'll want to fire the autocomplete, which will pass up the quest ID and is passing or failing. This will tell, so this will then bubble up to whatever logic we need to auto-complete a quest for us. And this would be done again in the host or the host controller, depending on where this gets received. And then finally, this is on click for UI. So these are two delegates I added for event dispatching. So the first one is for the quest log. So, and we'll get to this when we build out the quest UI, where you can actually select a quest, and so we want to know which quest we are selecting. And again, this is just, again, a reference to ourselves. And then this is the tracker. So this will go into the tracker component, again, a reference to ourselves. All right, so these are all the delegates that this individual object will use. So let's go ahead and set this up. All right, so under here, since this is generic, I'm just going to go and put in public, protected, and public. Let's just go ahead and just get this done. And under the first public, this is where I usually like to put all my constructors as well as the event dispatchers. So there's our events, blueprint, they're all set to blueprint assignable. So they can be found if I need to access it from the blueprint. Here's our constructor, and then here's our init quest. I'm going to leave these as green squigglies, and we'll come back and we'll fill them in as needed once we've defined the core signature. All right, so those are all the dispatchers, and I included this one up here since this is technically kind of like when we create a new quest, we need to initialize the quest, and so that's what gets called there. All right, so under protected, these are internal functions for internal use only. So we're going to be under protected. And within here, so this is our core quest state data, which we defined earlier. So again, these are all of the variables that we need to track and manage our quest. Again, all wrapped up in a nice, neat little struct, which has its own logic. And then this is the active timer objectives. So if we have anything, if there's a current, if we're on a current stage which actually has a timed objective, in order to try and minimize the amount of tracking we need, what we'll do is we'll add that into this timed objective array. So it allows us to track, and this will only get added in there as needed, and then removed as needed once we move out of that. So it's just a way for me to track what's there, so we can kind of really get very targeted when we want to update those timed events. We have the initialize quest stage, then we have move to next stage. This is a unique delegate, and this is going to be used for updating quest objectives. So there's two ways you could do it. One way is to just iterate, go through each quest in the quest log, which is active, and then go into the stage and iterate through and trying to find it. But that, if we do it that way, it would be done on the game thread. And if it's done on, and if you have, the more quests you get, the more time it's going to take away from the game thread, which means you could start to slow down your frames per second. So in order to minimize that, to mitigate that, right, and not block the game thread, we're actually going to use parallel processing. So what's going to happen is that each one of these, just like when we add a quest to the quest log, we will attach the quest log to events here. We're also going to attach an event here back up to the quest log, so that the quest log, instead of having to iterate through all of the active quests, and this can be very useful for games where you've got multiple quests open at one time, very much like, say, a Bethesda game, where you pick up more quests and you seem to be closing them for a while. And so the more quests you get, so rather than iterate through each quest to see which one we have to update, we'll just shotgun out the objective progression, and we'll let each individual quest determine that on a background thread, and so this will prevent us from blocking the game thread. So we'll see this getting attached and detached when we start getting into the component in the next video. but that's what this function's for. The check objective complete, again, this is all logic. So this is all passing objectives, this is all failing, this is all branching. So based on the stage, yeah, that will tell us which logic set to use here. And then this is our broadcast. This is our progression broadcast, which will then broadcast up to the components, and then that will then get broadcasted up to the host. So the idea is that we want the quest log component here to act as a facade around the actual quests in the questing array. And we'll see that in the next video when we go and create the quest log component. And then we have the start time objective, again, just a function, just to kind of keep things nice and neat. All right, and then finally, let's just bring in all the public functions. So these are all the functions that are going to be either used in between the host, which is the quest log components, or these are functions that can then work their way out. So some of these, which are like blueprint pure, these functions are going to be used more for the quest log UI, where the ones which don't have any function tags, these are actually internal use for the quest log components itself. So again, start timer, clear timer, quest update tick, that's going to be taking delta seconds. This is just get quest row handle, passes back the row handle. This is the quest data, get quest category. This is the quest objectives. So if we needed a list of the objectives by the stage ID, then we have quest name. Again, these are all just little helper functions that I added on here. And most of this is useful for, again, UI. And then here, again, these are all internal again. So we have load, save data, attach and detach. So this is how we're going to attach and detach to the quest log so that we can do parallel processing. And then we have the can archive this quest, can turn in this quest. Again, these are just internal functions that are going to be used for determining what we need to do within the quest progression. And I think this is more for this stuff gets used, I think, a little bit more in the quest giver when we get to that component. All right, so now that we've kind of defined it, so let's start from the top and work our way down and get the implementation done. Okay, so let's get started with the top here. So here we are, this is the constructor. So we always have to have one of these, so I'm just going to go ahead and fix it. But there's really nothing here in the constructor that I'm going to be doing, so I'm just going to go ahead and do that. The next thing is going to be our initialize quest. So I'm going to say show potential fixes, and we'll open this up here. So this is our potential, this is the initialize quest. This will get called every time we want to add a new quest. And all we're going to do is just run 3 lines of code. So again, this is the quest ID, so we're just going to go into our current quest state data struct and set the quest detail state there. And then on the struct, we're just going to run the initialize quest, since that's where that is. And then once the initialize quest is done, then we'll initialize the stage. So this function will only ever get called in one place, and that will be on when we say add new quest. All right. So that's the only function there. So then let's come down to our protected section, and we'll start with initialize quest stage. So let's go ahead and run that one. All right, so initialize quest stage. So this is everything we need to do to initialize a new state, the next stage, as we move from stage to stage. So the first thing is we're always going to validate our table, and then current quest state. Then all we're going to do is just run initialize quest stage data. So we already have this on within the logic, so we just run that function. We then are just going to broadcast up, and we'll get to these broadcast functions a little bit later, but here we're just going to say update. So this is the type, this is the quest, and then we're going to say this is and it's going to be in progress. Active timer objective, right? So we just want to clear this out that way, yeah, and then we'll check to see if we need to add any in. And then we need to do some pre-checks. So what we'll do is we'll run through each of the objectives in the current quest stage, and I'm going to do this by reference since this is just referential data, and check. So if we have an objective which is of type collection, we're going to call the on check for external objectives, and we're going to pass in the objective ID. So again, this is for collections only, so that's when we'll call this. And then if we have a timed quest, this is an active timer, then we'll go ahead and add this into the active timer array. And then once it's in the active timer array, we'll check to see if how many we have. If we actually have something which we need, then we'll say start timed objective. So that's how we'll do it for the start timed objective here. Yeah. Take that extra E out. All right, so that's pretty much initializing the quest stage. Let's go to move to next stage. So this is actually doing the move for us. So let's just go pull that. So every time we move from stage to stage, this is what gets called, and this function will manage the move for us. So again, this is where we want to check to make sure we have a stage ID. If we don't, if this is set to, if this is not none, right? So we actually have a current quest stage ID, whether it being a branching, a passing, or a failing. As long as there's an ID there, we're going to say broadcast 8, we're updating, going to our next stage in progress, and then we'll run our initialized stage. Otherwise, if this is none, we don't have a new stage to go to, then the quest is over and we need to start evaluating the quest. So this then goes to current quest state outcome. So if the quest stage history is passing, so if the last stage that we did was we passed, then we will assume that the quest is passing. If the last stage failed, then we'll assume that we failed the quest. And so here again we just broadcast up. This is at the quest level, and then we're going to say current quest state, and this is where we'll put the outcome. Quest state, update the rewards. So this will then get us to start iterating through the awards system. And again, this is all done here on the current quest state. And then we have the current quest state here, and this is where we actually will set the flag to say that this quest is ready to be handed in. If it's failed, we don't hand in a failed quest. We just, it just vaporizes. But if it's ready to be handed in, we'll flag it for completion, so that when we go back to wherever we have to hand it in, it will note that we're ready to now receive our rewards, and it will be handled externally. Current quest state, if it's an autocomplete, we'll then go ahead and automatically complete it. So that's why we have to set this flag first. So then whatever's doing the autocomplete will then just say, okay, check, just to make sure we're ready to do it, and go ahead and do it. And again, this is just taking the row name, and we're setting autocomplete to true. If it's a fail, we just do the same thing. We will run the autocomplete regardless, but we're going to set this to a fail. So that if there's anything that we need to do within the host to clean this up on a fail, we can do that there. So that's all that's handled there. So that's just moving from stage to stage. So this is listen, update, objective progress. So I'm just going to go ahead and run this. So this gets handled on each one of the quests, and this is gonna. So what's going to happen here is that we're going to get the objective progress coming in. So here we're going to take a look at the amount. We're going to make sure that this is greater than 0. If this progress is 0, then just don't do it, because we have to have something greater than 0. And then what we'll do is we'll iterate through the current stage objectives, and what we'll then do is we'll say if the objective ID is equal for this objective, then we'll do one of two things. If this is a collection, we'll just take the amount and put it straight on the progressive amount. If this is not a collection, i.e. it's anything else, then what we'll do is we'll then just go ahead and run the update objective, which does the plus equals instead. And again, this is just on the objective ID, and this is all sitting in the quest stage, current stage, objective progress. And then check objective is complete. So this is once we've done the objective and we've updated the objective, then we still need to check to see if it's complete. Because if it's complete, then we can say, okay, we're done, and we're one step closer to finishing the stage and then moving to the next stage or finishing the quest. Otherwise, so that's where we'll do that, and that's again done here or here. And again, it's a separate function just so that we can reuse that logic. And then here it is, objective complete. So let's go potentially fix that. All right, so this is how we check to see if an objective is complete. So we have the objective ID. So the first thing we do is we'll go into current quest state, and we want to get the actual objective. So this is the core quest objective. Right, so that will go pull that back for us, and that's why we have this on the state and this function here, just to make things a little bit easier. And then this is the current amount. So again, we'll now go into the history and find the progress amount, and then we'll do a quick check to see if the current amount, which is the progress amount, which we updated here in update objective progress, is greater than or equal to the objective amount, which is the amount which is on the record in the data table. So if it's greater than or equal to, then we have a success, right? Otherwise, if not, then we're not going to do any updates. So here, passing. So for me, we will update the rewards by objective ID. So this is where we'll go in, we'll check the objective ID, we'll update the rewards by the objective ID. If it's failing, there are no rewards. If you wanted to be kind of evil to your players, you could do an update created rewards here. If you wanted to say give someone negative XP for failing a quest, okay, you could do that. But for me, I'm just going to keep it simple and just you just don't get any reward. But yeah, if you wanted to do that, reward and punishment, then you could put your punishment there. And then you've got branching. Branching just works the same way as passing. We'll just update if there are any rewards on that branching, we can do that. And then objective time. If it's a time and we've met our time, then we want to clear the active timer. And then this is a function here, and we'll get to this when we get to the other public functions to help manage our timekeeping. So let's just minimize this and this real quick, get some more real estate back. So again, this is just how we check the objective is complete. And then once we've checked the objective complete, then we need to check to see if the stage is complete, and that's what gets run here. And that is here. All right, so that's the objective. So this is the stage. So once we've checked the objective, then we'll check to see if the stage is complete. And then this is kind of how we'll start setting it. So we actually have two types of rule logic. We've got pass fail versus branching, and right now since it's a binary set, it's either one or the other. So if it's going into pass fail, then we'll check to see if there are any failed objectives complete, and if there is a failed objective, then we'll say move to next stage. Otherwise, we'll check for any passing objectives. So first we start with failed, because fail takes precedent over passing, and then passing will yeah, then we'll equate the passing. If that's true, then we'll move to next stage. Otherwise, if we don't have any failing, we don't have any passing, then everything falls through. We haven't finished the stage yet. And then if it's a branching, same idea. Check to see if we can move. Otherwise, if we didn't meet any of these, then we'll pass on through. And so that's all that does. All right, so now we're getting deeper and deeper into the logic sets. Let's take a look. So this is all the parsing. This is what we do for parsing objectives. So again, this what we're doing is we're checking to see if we're ready to move to the next stage or not. So I'll leave that up for now. And no, we'll close it. All right, so again, this is all parsing objectives. So again, we have the counter. We're going to iterate through the current quest data, current stage, and looking for, and this is, again, this is our record. This is the information. And then what we want is, we want to look at all of the objectives that are not optional, right? Because this is the minimum amount of objectives that we need to pass in order for us to pass the stage. Optional are things that are on top of the minimum number. And then we have objective rule, so make sure we're set to passing. So, and if we're passing, then this is how we're going to count all of the passing objectives. And there's our counter there. So what we're doing is we're just making the count, but we also need to make sure that we have the minimum number of passing. So when we were on that stage, back when we were doing the quest row, we had to create this little function, say get minimum number of passing objectives, and that's all that does. So we can't just take a look at the number of passing number of objectives, because we could have passing, optional, and failing. So what we need is just the bare minimum number of required to check our counter against. And then if our counter is equal to or exceeds, which it should be equal to, then we should go broadcast progression update, and we'll say the stage is now being updated, it passed, and then we will run update stage rewards, and then we'll say get set next stage, and then that's set to true. This is the pass fail stage on that state. So this is just telling our state object to go ahead and do all the things that we need to do for all of the state variables to move us to the next, to start moving us to the next state. All right, so for failed, we're going to come down here, and for fail objectives, it's pretty simple. Unlike with passing, if you fail one, if you could have, even if you have 5 criteria for failing, if one of those criteria is met, then it's a fail. So we just need to worry about the first failed objective that we hit, that we've met. So again, here objective rule failed. So we go through the rule list again, looking for fail rules, and then we'll do the current objective. So this is where we're going to see, this is the progress, if it's greater than or equal to the amount. So again, checking that information to say, are we greater than or equal to, and if the progression has been met, then we're just going to fail it right here. So broadcast out, we failed the stage, set it to fail, and we'll say set next stage, and we'll use the failure logic by making that false, and then we have clear active timer. So we'll clear any active timers because if it's a timed quest, we'll clear it there. Boom, 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 and if that's true, we'll return true. Otherwise, if we didn't find anything, nothing failed, we'll return false. And then branching is the last one in this list. Branching works very similar to fail. The only difference is we're looking for branching rules, and here again it's the same idea. It's very similar. The only difference is we don't have any timed events, and we're just looking to see if we need to branch them. Instead of passing true false, this is where we'll pass the objective ID, so we know which branch, which new stage we need to move to. All right, so this is for broadcast. I'm just going to go ahead and fix both since they're both overloaded. So as you can see here, we're always going to be broadcasting something up. That way we can broadcast that into the UI if we wish to use it. So let me go find that information. So again, this is an overloaded function, and so a lot of our broadcasts are just going to be using type and state, and so I just pass in type and state, and this is usually for stage and quest update progression, so we just need type and state. Any of this information is just default, so I'm just going to leave it as passing these defaults. But then when we come down to the actual function, and this is the one which I use, we'll call this natively if this is an objective, right? Because we have additional information like the objective ID and the amounts added on. But then this is what will get called all the time. So this is on quest progression update. So the nice thing about overloads is that you can, you can really save yourself some, duplicate coding by using the overloaded. So again, here we're just going to create this update progression object that we're going to pass. We're going to broadcast up to the game. So this is the type. So type passes through quest details, quest stage ID. That can actually come from the current state always. The outcome, and then we have the objective ID, and then the amount. And they all just get added into this object, and then this object will then get broadcast on this on quest progression update delegate. All right, and then finally we have the start timed objective. So if we have a timed object, an active timer, all we're going to do is we're just going to broadcast back up to the host, which is for us is going to be our core quest log component, and we're just going to say this object, this quest needs active timing. That's all that is. So we're just going to pass it back a reference to ourselves using a this pointer, and then we're just going to set that to true. And so when we get up to the quest log in the next video, we'll kind of see the other side of this, so that it'll show how we're tracking for anything which is active time. And we only do this only if we come across an objective that it needs active time required. All right, so let's go to core quest objective. All right, so here we have restart active timer. So restart clear. So restart is used when if we're saving and reloading, right? If we have an active timer, we want to be able to pick up from where we last reloaded. And so that's what these functions do. So restart active timer is just if we're reloading a game, right, and we want to and we're rebuilding the quest log, this is what gets called, and it will say start active timer. So it'll say empty. So we'll just make sure everything's empty. Then we'll iterate through the current quest states to see if there's anything active. We should have an active objective ID. And then we'll say active timer, and then we just say restart the time, which will then broadcast back up to the host or the quest component to say, okay, start your time, start ticks. So that's the restart, and it's only really used when we reload the quest log. Clear active timer. Again, this is just a simple little. All this does is it just goes back up. Instead of broadcasting a true, it's just going to broadcast a false. So again, this will tell the quest log to no longer track the timing of this quest. And then finally, we have our update tick. And here again, we're just going to do active timer objective, and then we're just going to call this function here, which is our listen update objective progression. So this is we can call it, since this is a function, we can just call this directly. We don't need two versions of it. and that's just going to be how we're just going to, and again it's just going to go through and all we're doing here, and this is the reason why we're going to have a separate array to manage this. That way, if there's no, if this is 0, this will never get called, or if we have 10 objectives but we only need one objective, but we will only ever call for the timed objective. We don't have to iterate through everything to see if we need to update it or not. So it makes it a little bit more efficient when it comes to time. All right, so now we're at the functions that we need for UI purposes. So again, blueprint pure. So let's go ahead and fix these real quick. So this is the get quest row handle. And all this is doing is just acting as just a function that just goes ahead and just gets the row handle, which is set on the quest details. Get quest data. Just go grab this real quick. So this just goes ahead and just grabs the state object. This is really more for saving and loading, but I just made it so that we can just grab it in case I needed it for the quest log. And then we have the get quest category. So I'm going to say show potential fixes there. Again, this is just purely for UI purposes. So again, this allows us to go get the quest type. So we'll check to see if we have it. If that's all good, then we can go get that detail. Otherwise, by default, we'll return miscellaneous. Get objective details. So let's just go get that. All right, so that's current quest state. Again, checking to see if we have this. Then we're going to check to see if we have the stage, if it contains the stage. So what we're going to do here is we're going to run a contains on the stage, and then if we have that on the stages, then we can get the quest objectives. Again, this is going into get record information back. So yeah, and again, this is purely for our quest log UI. And then get quest name. So if this was something that, as I was building out the UI, I needed to keep getting over and over again. So again, I just went ahead and just built it right here. Go into the quest data, details, and get the quest name. Description the same way. Yeah, no difference there. Get quest tracker description. So this is our tracker description for the tracker UI. And on click events. I'm just going to go grab both of these. So I'm just wrapping the on-click events just to make it a little bit easier, so I don't have to worry about creating bindings. So on-click select. So this is if I if I'm in the UI and I click on something to bring up the details, it'll say which one it is, and the tracker is the same. Yeah, if I want to turn the tracker on, it does the same thing. So it's just broadcasting up. So, and this will broadcast up to what's listening, and usually what's listening for the tracker is going to be the quest log component. This will be the UI. All right, so now that that's done, load save data. So this is for rebuilding. So this is all the logic needed to rebuild our quest. So let me go find that. And it's real simple. Since we're storing everything, since we're storing the state here, all we do is we just park this back into here when we're ready to reload it. Again, make our lives easier. Very simple. All right, attach and detach. So this is for allowing us to asynchronously update active quests. So let's go ahead and do that real quick. So I just called it attach and detach because this is where we'll attach the quest log component to each one of the quests. So to attach, we're just going to go ahead and run this. So this is the component quest log, and as you can see here, I've got a red squiggly, which means we need to add an include up here, which will be to the quest log. Where are we? There it is, call quest log component. All right, and this is actually looking at a on update objective progress. So I'm just going to temporarily comment this out for now, and we'll go ahead and in the next video we'll go and rebuild this. But again, this is how we will. So we're just taking the component, and what we're going to do is we'll attach ourselves back to the quest log. So when the quest log goes ahead and broadcasts on update objective progress, all of the current objectives in our active objective or our active quest list will all go ahead and say, okay, check to see if they need to update any current objectives for any current stages. And so that's how that's going to work. So, but since we have another little chicken and the egg there, I'm just going to go ahead and just comment that out real quick. And I'll do the same thing for this one too. This is so because the quest log, because we don't want to broadcast to, because the quest log is now broadcasting down to these objectives, right, or to these quests. We need to make sure that when a quest is finished and is removed from the quest log, we also need to make sure that we go back to the component and tell it to remove itself from its dispatch list. Otherwise, if it tries to dispatch to a component, to an object that is now null, we're going to have problems. So that's why we have the detach here, and that's why we have to do an attach detach here. All right, so again, we'll come back to this in the next video to go and re-enable that. And we'll also re-enable the code for the update as well, since it's going to, since we'll be going into the quest log. So we'll go back to the quest row and go back to dependencies and finish that as well. So that'll be in there. All right, can archive this quest. So just some more little functions. I'm just going to go ahead and stub these out, and we'll just go ahead and finish this up. So can turn in quest. I'll just put this one here first. So this is can turn in quest. So again, this is just looking at the RL quests. So this again will be used by the quest when the quest giver is looking at the individual quest. It's going to say, can I turn it in? Yes, I can. Okay. And then the other one is get current quest stage ID. Again, this is just a quick little one. So again, this is the current quest stage ID that we need. And then lastly, we'll go to can archive this quest. So this is the logic to determine whether we're going to be archiving a quest or not, based on how it's set up. So here we are. Again, if we have can archive this quest, we're going to say look at the outcome. If it's pass, set to true, then we'll say archive it. Otherwise, this is if we have a failed quest, right? And this allows us to filter out, because not all failed quests we want to archive, but there may be one or two failed quests where we might want to archive it because we might want to have future decisions on whether to give you a quest or not based on that outcome. So again, this will go and take a look at that additional check on there and return true if it needs to. Otherwise, if we can't archive it for any reason, it returns false. All right. Okay, so that should do it for for our quest container, our quest object. And so this is all the logic needed to manage a quest and all the data. And it's spread across the struct as well as the quest object. So in the next video, what I'm going to go ahead and do is we'll go over to the quest log and we'll finish up all the logic there, and we'll go ahead and implement the dependency, and we should be able to then get the attach and detach working, and then we'll see how, and I'll show you how you can then parallel process quest objectives asynchronously through the quest log component. Alright, so as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. And if you have any questions, feel free to leave them in the comments below. I will see you in the next video. Cheers. Have a good day.